So from that, I'd like to hand it off to Heather Kirkering. Heather is our USGS Science Coordinator for the Pacific Islands Climate Adaptation Science Center, and she will be moderating our next round of lightning talks. Take it away, Heather.
Aloha, everybody, and welcome back to day 2. Thanks so much for joining us. We had a great session with lightning talks yesterday, and so we've got another great lineup for today. We're going to have about 8 speakers who have a 10-minute section each, with 2 minutes at the end of that 10 minutes to do Q&A. So if you have questions during the presentations, please do enter them into the Q&A tab and we will get to them. The speakers today are going to fall into a few different categories. The first one will be changing landscapes, water resources. Then we have biocultural connections, then sea level rise and coastal resilience, and then marine and freshwater ecosystems. Our first speaker today, if you want to get ready, is Dr. Ryan Perroy. Ryan Perroy is an associate professor and chair at the Department of Geography and Environmental Science at the University of Hawaii at Hilo, and the director of the Spatial Data Analysis and Visualization Research Lab. He completed his graduate studies in geography at UC Santa Barbara and has an undergraduate degree in physics from the College of William and Mary in Virginia. Thanks for being here, and you can go get started.
Okay, great. Hello, everyone. Thank you for the opportunity to participate. I really enjoyed the talks from yesterday, and looking forward to continued wonderful conference today. I just wish we could all be together in person, but just soon enough. So yes, I'm gonna talk to you all about some projects that my lab is working on in partnership with a number of different groups. Next, please. So yeah, I run the SDAV lab, and it's here at UH Hilo, and we work on a number of different things. Next. Including a lot of work with high resolution mapping, and lately we've been doing a lot with rapid ohia death. Next. But we've also done work for, lava eruptions, and next. And also some work out in the outer Pacific. This is from Marshall Islands, where we're working on an agroforestry project out there. But all of these are related to high resolution mapping and looking at changes in the landscape. And so I'm going to talk about 2 projects today in the time that I have. And the first one, next, is on the island of Molokai. Next, yeah, there you go. And next one, please. And so this is a project in partnership with Kamehameha Schools, and it's in the Keawenui watershed on Molokai. Next. And this project's really being spearheaded by a student here at UH Hilo, James Kimo Melcher, and he's actually from Molokai, and this project is near and dear to his heart. He's concerned about the amount of erosion which is occurring on his island, and the impacts to nearshore resources. So just behind him there in that photo, you can see the Keawenui fish pond. And so the watershed that he's working in, it's got some pretty serious problems with erosion. Next. As you can see here. So Chemo's and what we're working on is trying to, first of all, get a baseline understanding for erosion and hotspots, and then thinking about, optimal ways to mitigate and minimize these issues. Next. Toward that end, he's using a number of different tools, including ground-based LiDAR and drones for collecting imagery. And the idea of the data collection is to be inputs for different types of models for thinking about sediment transport, and then also for thinking about if we were going to do some outplanting or erosion mitigation strategies like rock wall check dams and things, where to optimally place these in the landscape to get the most benefit. Next. And so this is just an image that he collected. Again, you can see a lot of bare soil there. Next. And we can just do quick classifications of that bare soil and feed those into the different modeling efforts that we're we're working on. Next. And in addition to the imagery we get from the drones, we can also get the three-dimensional data as well from the LiDAR and use those for the surface modeling efforts. Those little purple squares there, those are the locations of check dams, and in the virtual space, you can, put in fake check dams and see how that changes the hydrology and sort of think about those types of things. So he's sort of in progress right now, and we're looking for some good things coming out of that project. So that's one. Next slide, please. And there's a pretty important outreach component to this project as well. This is a photo of one of our pipes interns, and then also Evelyn, who is a high school student there in Molokai. So we're trying to get the local students there involved in the project and excited. Next slide. And so there's been outreach events at the local high school and trying to build relationships with the folks there on that island. So it's been really, I felt really honored to work on this project and looking forward to good things. Next. Next again. So the next one is going to be back on the island where I'm currently located on Big Island. Next. And this is in partnership with the County of Hawaii Planning Department. Next. And so looking at erosion again, but this is now a slightly different scale, and really looking at the coastal area for thinking about like appropriate setback regulations and things like that, which weren't necessarily used here. Next, this is a work that was started by actually Rose Hart, who is a former student, and now she's up in Alaska flying drones and doing work up there. Next, but what she was looking at was sort of changes to coastlines over time. And so she did some time series analysis work using historic air photos. You can see this sort of migration backward on decadal scale from the 70s. But we've also seen next some real short-term changes. So this is just 2 digital elevation models we generated over a 4-month period, and those white arrows, if you can see, there are places where there's been significant collapse just in that 4-month period. So I'm interested in questions about short-term changes and long-term as well, but capturing those changes in at scales, spatial scales and temporal scales that are meaningful. And in Hawaii, there seems to be a lack of imagery, a lack of data. And the situation's getting better and better. There's more high-resolution satellite imagery available and all kinds of different data providers, but still compared to the mainland, we're missing a lot of imagery from my perspective. Next. Rose's project looked at 3 sites, 3 small sites, and that was great. She was using drones to do that. Next slide. But I'm really interested in trying to do the whole coastline, and that's 400 and some kilometers. And towards that end, next slide, in partnership with the National Park Service and David Okita, we're developing a helicopter-based imaging system. Next slide. And it's got an integrated differential GPS and IMU, and basically it allows us to map much larger areas than we could just with the drones alone. Next slide. And this is, I like this photo of Aloha a lot. This is working with Aloha Kapono, a current TCBS student, and this is part of her work for her master's degree. Next slide. And so we actually just did a test flight with this system last week. Quick little flight from Hilo up to Honolulu. And next slide. Got about 2 centimeter resolution imagery. This is just, this disturbed me when I saw this image. That's a pretty important highway, and that, that cliff line is, it's active. I'm sure we got some time to go before it goes, but, getting this kind of data and information is quite helpful for us to monitor these changes. Next. This is another shot just showing the cliff line there. And again, where you've got that bare exposed rock and soil, that thing is active. Next. And so again, it's not just the imagery, but we can generate 3-dimensional models from these data using photogrammetry. And we're in the process right now of understanding our spatial accuracy. But again, we're talking about, at least in the spatial resolution, on a centimeter level, a couple centimeters. and hopefully going to get the vertical down quite tight. And we're working through this system right now. Next slide. So again, this is just an example of the imagery and the underlying three-dimensional model and hillshade relief model that we have here. So again, trying to generate these types of tools and allow us to on a more regular basis, acquire this type of information and look at these changes over time, because we need to understand how our coastlines and other parts of our island are changing. So that's my talk. Thank you very much. Just one more slide just to thank you. And if there's any questions, happy to take them and eager for discussion later on.
Thank you so much, Dr. Perroy. That is really amazing application of some advanced technology. So that's a great presentation to see. We do have a couple questions here. The first is, are drone-based LiDAR systems available yet?
Yeah, the answer to that is yes. There's a growing number of these LiDAR systems that can fit on not just the larger drones, like for example, the Matrice 600, there's a number that can carry, but there's even smaller ones that can fit on smaller drones. And so it's actually a really exciting area. They're still kind of pricey. My lab doesn't currently have one. We've got some ground-based things and other ones, and we're looking at those in the future. I haven't jumped into that space yet because I'm waiting for the prices to come down a bit. But the answer to that is yes, and that's an exciting growing area.
Great. Thanks for that answer. Another one is, what historical imagery or map data is available to extend these data setbacks in time?
So it depends on where you are. But for example, on some of our sites here on Big Island, we've got access, or aerial images exist. Going back to the 50s. There's satellite imagery that exists. Those archives. A lot of it is what is the resolution of those older data sets, and is it helpful for the questions that you're trying to ask? But yeah, there's air photos that go back to the 50s, in some cases even back to the 20s or such. It's just whether or not they exist for your area of interest.
Great. Let's see. We'll try. There's a few questions in the Q&A, so we'll get. I'll ask you maybe a couple more, and then I'm going to ask you, Ryan, to go to the Q&A after those two and see if you can help answer some of those. But one of them is, how are climate projections being incorporated into the models you're using?
Yep. So that's a great question. So at this point, we are working on the generating these elevation models and sort of understanding basically the landscape and these changes that we're seeing, including the future and these projections. That's a really critical part of that, and so we're talking to different partners about that. But that's not where my expertise lies in terms of doing that actual modeling. So I'm really happy to talk to other folks about how we could integrate our data sets into those. So we're talking to a few people now, but that's still, I'm wide open to collaborating with folks.
Great. And any indication of how the information on Hawaii will be used by the planning department?
Yes. So they're already through Rose Hart's work. They're already thinking about rewriting their shoreline setback regulations to incorporate some of the erosion rates that Rose has documented. And so the county's quite interested in this. And again, not just the work that we're doing, but again, the USGS is about to release, a coastline LiDAR data set and other sources. So, but for planning purposes and for permitting, so that the county's very interested to use a science-based approach, as opposed to what the existing regulations on the books are, which are like 40 feet. And there's no real justification for why that number was chosen.
Okay, thank you so much. Again, there are some questions in the Q&A that we just don't have time to get to, specifically around some of the work you mentioned in the Marshall Islands and potentially taking this work out beyond Hawaii into the Greater Pacific, and about the type of vegetative cover that you are able to map. So if you have a chance to get to those, that would be great. And Ryan's contact information will also be included in the documents that we send out related to the Science Summit. So please feel free to reach out. So thank you, Dr. Perroy.
Sure thing.
Very appreciated. Our next speaker is Dr. Stephen Gingerich. Let me bring him up. He is a research hydrologist with USGS and has been studying the hydrology of the Pacific Islands since 1990. His published works include studies in Hawaii, Guam, the Northern Marianas, American Samoa, and the Marshall Islands. Thanks so much for taking the time to present.
Sure. Hi, I'm Steve. Thanks for having me here. I'm going to take us out to Guam for a bit and talk about a project that USGS worked on with a bunch of partners. Started in about 2015 and ended just about 2019, last year. And that was funded by the Department of Defense CERDIT program. And so I'm going to talk about the fresh water availability in Guam with projected changes in climate. Okay, next. So we basically the project was to develop some climate projections for future climate and then figure out how freshwater resources would be impacted by this. So we have climate projections developed by the IPRC there at UH, used existing sea level rise projections, and then we used some models that were developed particularly for Guam, a watershed model in the south and a groundwater model in the north. And we applied those with these future climate projections to come up with projections of how future freshwater would look. And some of the other partners on this were University of Guam, folks out at Weary helped a lot with the on-site work, and they partnered with the University of Texas to look at some groundwater recharge questions. We partnered with the East-West Center as well that helped us with a lot of outreach and turning the data into usable science. Okay, next. So I won't go into all the gory details of the climate model. And basically get right into the projections. It's basically for end of century and the RCP warming scenario of RCP 8.5, which is the business as usual scenario. And essentially we took this global models and downscaled them for Guam using a very high resolution climate model of the area. And when we looked at the future climate projections, we found that overall rainfall would be about 6% lower by the turn of the century, with a wet season lower and a dry season actually a little bit higher. We expected drought conditions to happen much more frequently. But every 4 years or so, we expect to have drought conditions in the future instead of the 1.6 years that it's out of every 10 that it happens currently. One of the biggest surprises was that the temperature is expected to increase by daily average by about almost 6 degrees higher, and increase of days over 90 degrees up from 115 up to 257 days. So definitely a hotter future to look forward to. And then with some typhoon modeling, I met with Lansky and others, we found that typhoons actually might be less frequent, but when they occur, they're probably going to be stronger. So next. So then I mentioned the water models. We had a watershed model for southern Guam developed by the USGS. And for the northern Guam, this is mostly where the groundwater aquifer is located. We had a groundwater model that looked at the solute transport and the density dependent groundwater flow in the limestone aquifer of northern Guam. So go ahead next. We'll look at the impacts on southern Guam first. So using the watershed model with future rainfall and future temperatures and so on as input, when we ran the model, we determined, estimated that total stream flow across the southern Guam is going to be about 18% lower and ranging from 12 to 36% lower, depending on what watershed you're interested in. And also the ET, or the total evapotranspiration, would be about 14% higher in this area. And it's basically because the higher temperatures that we talked about are going to lead to higher ET. Next. And then we zeroed in on a couple areas of interest. One is the Ugam River, where the water department has an intake for surface water supply. And for that particular watershed, we determined that rainfall is expected to be about 4% lower, leading to about 18% lower stream flow by the end of the century. And it's basically, again, the higher temperature causing higher evapotranspiration and less water making it to the streams. So that'll have some impact on the surface water supply out of the Ugam River. Next. And we also looked at the Fenner Reservoir for the Navy. Since this was a DoD funded study, we definitely had to look at that. And we remapped the bathymetry of the reservoir, remapped the water supply model that we have for the reservoir operation, and then again applied these future climate projections and looked at some future demands and looked at some mitigative efforts that could be undertaken and what kind of impact they would have. And one of the things we looked at was lowering the intake for fresh water in the reservoir. If you lower it 5 feet, you'd get less than 2% of an increase in the water supply. If you raise the spillway, you'd have maybe a 3 to 4% increase in the water supply. If you did both, you'd have maybe a 5% increase in the water supply. I guess this result kind of shows, a 5% increase is not that useful probably for the amount of money that you would have to spend to undertake these efforts. But it was really the first time we could put some numbers on what kind of impact we could have on the system. Okay, next. And then if we look at Northern Guam with our groundwater model, which was developed for the Marine Corps back in the early, around 2010, 2012 or so, we were able to calibrate that to existing data and then look at future impacts again. So it's just showing the model mesh here and the 2010 data that we were able to use to calibrate it. So if we go next. We also had an estimate of groundwater recharge to the island. So we had the existing model that we had run for the original study. And then again, we put the future climate projections in there for the end of the century. And the map on the right shows the difference that about almost 20% lower recharge will be expected by the end of the century based on the future rainfall and temperatures that came out of the climate model. So we'll go next. And we plug that new future recharge into the calibrated model to look at what impact that will have on the groundwater supply. So one of the first things we looked at was using, we put about a 6.6 or a 2 meter sea level rise into the model, and the map shows the wells, the purple dots show the wells where the salinity of the water from that well would get higher based on just a 6.6 sea level rise. And then in the middle panel, we plugged in the estimated future recharge, which was 20% lower. And you can see all the dots that show up. These are all the wells where the salinity would increase into a higher salinity category. So basically, you'd be producing saltier water from the wells. And of course, the size of the circle indicates the amount of increased salinity that you would have. And then finally, on the third panel shows when we could plug both effects in, both the sea level rise of 1 meter, 3.3 feet, and the 20% lower recharge. You can see where the impact is on those wells. Okay, next. And then finally, we looked at some mitigation strategies for that. And this is a map showing different wells that would be improved by having the depths shallowed up, so they maybe re-drill to a not so deep well. Other wells that would be better by reducing the withdrawal. And then the yellow ones are wells that would be better by reducing the withdrawal and decreasing the depth of the well. So we'll go to the final slide, just showing the study team members that we worked with out there. I want to thank all those folks. And that's it for now. So it was a very brief recap of a very long project. So I can take any questions now.
Thank you so much. That was really great to hear some information about freshwater resources in Guam. Let's see, there's a question about how people are receiving this information or using the data for any planning.
Well, I think they're certainly considering it. The folks at the University of Guam, as part of the team, are on the planning panels and the aquifer commissions out there. So they're as they move forward and plan, they're using this information. It's very expensive. They can't just go out and replace all the wells and change all the the infrastructure. So I think as they move forward, they're going to be able to incorporate this information if they have to replace a well or something like that, change a pumping rate. So they'll be able to kind of use this, as an ongoing planning tool into the future.
Great. So that you just named a couple of your stakeholders. So, and I guess in addition to that would be the DOD. Are there other ones that you're working with?
Well, of course, the water department out there, the Guam Water Supply, and the DOD and University of Guam and Guam EPA are all kind of get together for these, I guess I'm not sure what period they're having them now, but they have, the Northern Guam Lens Aquifer meetings where, they consider this information. So it's mainly, all the big water users and regulators in Guam are all quite aware of these results.
Great, thanks. A couple more questions for you. Which GCMs were used for the future climate change projection? And why? Sorry.
I was going to say, I don't know the names. It was an ensemble. I think it was the 5 kind of best performing models that were sort of grouped together to give us the results. I don't know offhand which of those 5 that were used.
Okay. There are a couple of questions regarding that in the chat. So when we wrap up, if you could get to that, that would be great.
Sure.
Just a couple maybe quick questions. Are there new replacement wells being drilled to replace the ones with saltwater intrusion?
Actually, I'm not quite sure. Offhand, I haven't have my fingers quite on what the most recent drilling is going on, but I know that some of the new planned wells for the future, they're taking into account the depth issue and drilling them much more shallow based on some of these recommendations. But I don't know about any particular replacements at this point. We'd have to talk to some of the Guam folks to find that out.
Okay, and one last one for you, then we'll move on. Is there any catchment on Guam? And with increased salinity in wells, should they be considering other freshwater sources?
Well, the Fenner Reservoir in southern Guam is, the Navy owns that, and they supply their base with it and some of the civilian water as well. There's really no other catchment areas at this time. I think, that is a possibility into the future. I don't, of course, there's quite a lot of hurdles, expense and regulatory hurdles and such to jump to make that happen. But I think it's something that could be considered in the future.
Great. Thank you so much for taking the time to present and answer those questions. We're going to move on to the next speaker, and I'll send Steve over to the Q&A for those we didn't get to.
Okay, thanks.
Thank you. Yep. So our next speaker is Dr. Karen Thorne. She's a research ecologist at USGS, the Western Ecological Research Center. Her research focuses on climate change impacts to coastal ecosystems, including sea level rise impacts to mangrove ecosystems in the Pacific Islands. Her research includes field data collection and modeling to inform management decisions on local and regional scales. Great to see you. Take it away.
Thank you. Well, good afternoon, everybody, and thank you for asking me to speak. I am going to focus on a fairly large project, and I get to be the spokesperson today. But our project is looking at the vulnerability of mangrove forests in the Federated States of Micronesia focusing on 2 islands, the island of Kosorai and Pohnpei. So there's a handful of people from the USGS, and then Rich McKenzie and then Maybelline Oplong from the US Forest Service. And, you know, I was really asked to talk a little bit more about kind of the biocultural connection. So I took that as, you know, how is our sea level rise vulnerability assessment of this ecosystem being used by the community? And so I will be kind of circling back to that throughout the talk. And oh, I also want to mention all of our local partners. You know, I should have put everybody's icons or logos on here, but the Micronesian Conservation Trust has been a main participant in this project. The U.S. Fish and Wildlife Service was really one of the original people to sort of stand it up on one of the islands. The Conservation Society of Pohnpei, Kosorai Island Resource Management Authority. It's really been a great experience to work so closely with those groups on this project. Okay, next slide. So as I mentioned, I'm going to focus on the importance of this resource management partnerships in developing a sea level rise vulnerability assessment. You know, sea level rise is an eminent concern for island nations, countries, shorelines, and you know, for myself and others, like we really want to do cool science, but we want to be sure it's useful to people because we're concerned. We're concerned about maintaining our ecosystems and our livelihoods and community kind of integrity moving forward with sea level rise. Next slide. So quick rundown for people not familiar with mangroves. So mangrove forests in Micronesia are native. They can build their elevations to keep pace with sea level rise. So in terms of a living shoreline, they're really great to have and maintain so they can prevent flooding and submergence. But the response of mangrove forests can vary a lot by region, by island, by watershed. So there's lots of uncertainty. And then different mangrove species trees have different tolerances to flooding and salinity. And the forests here in Micronesia are huge and beautiful and really diverse. I, up until this point, had worked in mangroves in Florida where they're like scrubby little bushes. So it was really amazing to go out there and see these like extensive forests. And then modeling can be daunting for people to interpret, but it really can be helpful to talk about the future, which hasn't happened yet. But we want to know when things may be vulnerable to flooding or loss, and then if there's particular areas that may be more vulnerable, so we can plan, you know, adaptive management or intervention sort of measures. And in this particular region, there was very little information on this topic, but a really engaged and sort of end user community. And then these particular communities, it's still really important for subsistence living. You know, I asked Maybelline, who is a Forest Service employee and a recent student to the University of Hawaii Hilo, is from the island of Pohnpei. And so recently asked her, you know, what do the mangroves mean to you? And she sort of looked at me and said, well, they're part of our, they're part of our life. They're part of our community. So people use them for timber, food, flood protection, just really, you know, it is a big part of their culture and lifestyle. Next slide. So specifically, what was the project and how did we have science to inform climate adaptation? So you can click through this for me. The question was, how will the mangroves respond to sea level rise? Next. And we had 3 objectives. So if you click through those, one was to develop a model that was relevant to the island and ended up becoming transferable to other islands. And then do scenarios, and in that process, engage stakeholders throughout it and provide opportunities to learn more about sea level rise and their mangrove forests. So if you look at this picture here, this is us last year on island. We're installing surface elevation tables that will monitor the mangrove forests. And these are folks from Coastal Island Resource Management. And so we used an opportunity to sort of train them on how to install these instruments, how to read them. They had lots of interest in kind of deploying these around for a monitoring network. Next slide. And you can click through the different bullets. So we have had on-island sort of trainings and in the field, like I just described. And then here is a picture of a workshop we had in the fall or the spring of 2019. Next slide. And then, as I mentioned, we have collected a lot of field data, but then we've also engaged different management groups on the islands to assist in the data collection and provide training, because ultimately they're collecting the data when we're not there, and they want to be able to monitor their mangrove forests through time with sea level rise. Next slide. So what are some of the products being created? So we ran the modeling with a whole bunch of field data that I just did not talk about for 7 different regions of the island. So there's a map down on the right of what the island of Pohnpei looks like, with the green area being the mangrove forests. And we ended up running the modeling across 4 sea level rise scenarios. So something low, moderate, high, and more high. And then how the elevation of the mangrove forest in those locations would change over time with sea level rise. Next slide. And then to translate that to what people would see in the forest, we took the 5 dominant mangrove species, and they have different elevation and flooding and salinity tolerances, and then sort of predicted with the modeling how the forest composition may change over the coming century. And this was really important because each one of these species or composition of tree species provide different resources to the community and sort of the ecosystem in itself. Next slide. And we then translated all of those results into maps. So you could look at the island of Pohnpei and say, this watershed is more vulnerable to sea level rise over the coming century versus a different watershed. And then talk about how the forest composition would change. The take home from the modeling and the map you see here is for the higher sea level rise rate, so 67 centimeters by the end of the century, is that there's modest change of the forests over the next 40 to 50 years, but really at the end of the century, the forest composition begins to change. Okay, next slide. So we have been engaging throughout the process, but science delivery was focused on in-person meetings. So one thing in these islands is that face-to-face communication is best. Internet is spotty and unpredictable. Most people have smartphones, so you can get access to information. So traditional delivery of I'm putting things on a website isn't always the best. So we decided to go a bit old school and created reports that you can download online, but also our hard copy, and then creating sort of YouTube videos and a 2-page fact sheet. However, a lot of these plans have changed. We expected to have workshops, but with COVID, the country is currently closed to any incoming citizens. Okay, last slide. So in conclusion, we were able to do sea level rise modeling for the mangrove forest and have a range of sort of possible outcomes. And that it's a very useful tool, and engagement with the community has been very rewarding. And there's a big science need in this part of the world. Thank you.
Great, thank you so much, Dr. Thorne. It's great to get a perspective of another part of our region. during our lightning talk. So we do have a couple questions coming in that I wanted to get to. First one is, are mangroves forest on the islands important to fisheries and other particular or endangered species? I guess not other, but
Yeah,
yeah.
That's a really good question. So there is no endangered species that I'm aware of, but please someone correct me if I'm wrong. But of course, fisheries and crab and shellfish are really important to the community. And then there's sort of this linked, there's these beautiful coral reefs, and they interact and provide habitat for both.
Great, thank you. Let's see. Did you find significant areas of freshwater wetlands or estuaries likely to shift to mangrove wetlands?
Oh, good question. So we did look at that some, but the topography on this island is like many islands where it's very steep. So there's a fringing area that mangroves and intertidal ecosystems can be. So it's fairly constrained on how much upland migration can occur. So there's going to be some through the watersheds, I would presume, but it's really limited. You can see the picture there. It gets steep very quickly. So it's not suitable, yeah. Yeah.
We have time for one last, hopefully, quick question is, and then there's some on the Q&A again, I would like to direct you to after this, but where is the elevation of a mangrove forest measured from? Like the actual, how you're taking the measurement.
Oh, good questions. That's a great segue because Dean Gesch is talking later this afternoon, and he's actually going to probably talk about the data that was collected for that.
Okay, great. Well, again, thank you for that. And if you can head to the Q&A, that would be lovely because there are a couple of questions that we did not get to.
Okay.
Thank you. All right, I should have mentioned previously that we're going through the biocultural connection talks right now. So that was Dr. Thorne, and next we have Dr. Christian Giardina. Christian is a research ecologist in Hilo with the USDA Forest Service Institute of Pacific Islands Forestry. Originally from Long Island, New York, he's been living it with his family in Hilo since 1998. With graduate degrees in religion, forestry, and biology, and a postdoc fellowship in NREM at UH Manoa, he has been studying climate change impacts on forest, landscape restoration, and biocultural stewardship. He represents the Forest Service on the Hawaii Conservation Alliance, Steering Committee, the USDA Southwest Climate Hub, and the Governor's Task Force on greenhouse sequestration. So thank you so much for being here. I look forward to your talk.
All right. Aloha mai kako. Want to start by a mahalo to the organizers for inviting me to share some thoughts on biocultural conservation. There are some bioculturally focused projects that I could have addressed in the talk, but given the complex events of the last 6 months, I decided to take a broader look. I'll start by sharing a few of my assumptions behind the talk. First assumption is, as an older Italian American working in a federal agency, I'm not the best person to give a talk about biocultural conservation in Hawaii, but I'm gonna try to do my best. Next. I want to acknowledge the fact that I'm not the best person by sending a mahalo to my Kanaka Iwi colleagues at IPIF and outside of the Forest Service who have done an enormous amount of work to help me and my agency to grow professionally and personally. Assumption 2 is we Malihini agency types are not as fluent in the perspectives and practices of biocultural stewardship as we could be, arguably as we should be. This isn't a criticism of the really good work across agencies to bridge knowledge systems or address social justice or equity issues in Hawaii and the US affiliated Pacific. It's a simple observation. Assumption 3, in Hawaii, events on Mauna Kea over the past decade highlight that after 120 years of conflict over ridge to reef resource stewardship and protection of sacred sites, we still have a lot of work to do to help heal the wounds that divide us, the big us. Assumption 4, the work ahead of us encompasses revisiting a few things: how we view the links between history and the environment, what we hold to be equitable and socially just, and the actions that we take to bring equity and social justice to our agencies. Final assumption: if we agencies aren't actively healing the sources of our divisions, our ability to effectively address climate change will be compromised. Next. Gavin et al. In a seminal paper on biocultural conservation described this issue more simply. When conservation planning ignores socio-political context, success rarely ensues. Next. A widely practiced skill within conventional conservation is shying away from socio-political context. We hug trees and kiss butterflies, but reflecting on this map, we know that nearly all of our most treasured conservation areas in North America, whether Forest Service wilderness areas or national parks or state protected areas, were the ancestral homelands of indigenous people, communities that have spent centuries now addressing the loss, the theft of these homelands. Conventional conservation has worked hard to see the erasure of the painful memories associated with these facts, and these erasures continue into the present. So there's a simple conclusion that I think we can come to from some of these observations, and that it's our responsibility as agencies to understand, engage, and address our colonial history. If we don't do this, it will be really hard, I think, maybe impossible to authentically engage biocultural conservation. This erasure has a history in Hawaii and the US affiliated Pacific Islands as well. Next. Following the 1893 overthrow of the Hawaiian nation, 1.8 million acres of Kanaka-Iwi lands, nearly half of Hawaii's land base, were ceded to the US provisional government and eventually US Republic of Hawaii without the consent or compensation to Kanaka-Iwi or their sovereign government. US apology resolution. This theft was so egregious that Congress passed and President Clinton signed this federal legislation into law on the 100th anniversary of the overthrow of the Hawaiian Kingdom. In brief, it apologizes for the theft of Kanaka-Iwi lands that were used to establish the Mauna Kea Science Reserve, the campuses of the University of Hawaii system, including our Institute of Pacific Islands Forestry, where we sit, Hawaii DLNR's forest reserves, natural area reserves, wildlife sanctuaries, and state parks, and Hawaii's 2 largest national parks. Critically, it wasn't just land that was ceded without consent or compensation, but also freshwater resources and nearshore and offshore resources. And in the Pacific, these issues aren't restricted just to the state of Hawaii. And so an important question for all of us, I think, is how do we engage socio-political context in our efforts to design and implement climate adaptation and mitigation actions across the diverse geographies represented here at this meeting? Next. Collective memory is critically important. It is shaped by and in turn shapes perceptions of justice and injustice, thereby impacting the claims and rights of Native Hawaiians. This was a very compelling paper for me. It was in part compelling because we agency types have been getting strong prompts about our collective memory issues, that our conventional conservation collective memory may not align with historical reality. I think we're at one of those important moments in history where it's time to come to terms with what might be called collective memory dissonance. Here are some thoughts on the what, how, why we might address this dissonance from an agency perspective. Next. I think it's valuable to think about conventional conservation as operating along a decolonization axis, this axis here on the bottom of the figure. When I first moved to Hawaii with my family 23 years ago, neo-colonial resource management, for lack of a better term, defined agency relationship to place. In this worldview, resources and biodiversity were seen as commodities, and community was engaged on good days as a distraction, but on bad days as an adversary. Next. We all have seen a lot of change on these perspectives, both within agencies and outside of agencies. Part of this change is because Kanaka Oiwi and Pacific Islander professionals have helped from the inside to reshape conventional conservation, but also because conservation professionals across the board love and protect species of concern. We care about our places, we work hard, we're devoted to our causes, we're passionate and effective given the limits of funding and staffing. And so people on the ground have formed alliances, whether with agencies or communities. And this has really helped to transform, I think, how we operate as agencies in our places in the Pacific. For all these reasons, agencies, including the Forest Service, have moved beyond the neo-colonial model to this more integrated model that considers multiple knowledge systems, engages a Hawaiian knowledge system, and it diversifies our perspectives on resource stewardship. This is a comfortable place to be, and I'm expecting that many might ask, why do we need to move beyond this model? I think part of the answer is that really tireless and patient organizing by people who have been on the receiving end of state and federal management strategies and mandates has really shifted the work under our feet. But another part of the answer is that places like Haena, Kaupulehu, Miloli'i are demonstrating that more change is possible. Next. And so I think in the past decade, we in conventional conservation have been encouraged, nurtured, trained, and where needed, confronted to expand our vocabulary, grow our understanding of the complexity and depth of the Hawaiian knowledge system, and to embrace multiple ways of not just conceptualizing, but conducting conservation, including honoring both the love that many in our communities have for their places and the deep knowledge they bring to the stewardship of their places. Next. So I think we're in the beginning stages of appreciating that this kin-centric stewardship of place model has a number of really powerful elements. And as a last conclusion to leave you with, this concentric stewardship of place model that really emphasizes embracing multiple knowledge systems and community as a key part of the conservation equation, that we could be investing more in this model as a way to address climate issues across Hawaii and the US affiliated Pacific. And with that, mahalo.
Thank you so much, Christian, and thanks for bringing that perspective to this focus area. We do appreciate the work you do to make these biocultural connections. And we do have time for one question that came in, was about the need at the graduate student level to support the next generation of scientists and managers and these approaches. And if you have a thought toward that.
I've been a part of a handful of conversations at UH Manoa and UH Hilo, and I have heard unanimously, uniformly, 100% from graduate students that biocultural stewardship concepts, ideas, colonialism, they're all woefully underrepresented in our ecology training programs. That's not my opinion. That has been the consistent message I've gotten from graduate students across the UH system. So we could do much more to invest in those areas.
Great. Well, I hate to move on so quickly, but we need to keep the time, so I appreciate it. Let me see. It looks like maybe a couple questions came into the Q&A, so I'll send you that way when you get a chance. Next up, we have Dr. Miwa Tamanaha. She earned an economics degree from the University of California and spent 20 years working in environmental policy and justice advocacy in Mexico, California, Tanzania, and here in Hawaii. Her ancestors came to Hawaii from Okinawa to work sugar plantations, and she is the 5th generation to call Hawaii home. She served as a policy and communications director for the Santa Monica Bay Restoration Commission and as executive director of KAHEA, the Hawaiian Environmental Alliance. Today, she serves as co-founder and co-leader for the Ku'uaina Ula A'omo, or KUA, as we say, bringing the expertise and voice of Hawaii fisheries, farmers, gatherers, and families to efforts to solve some of Hawaii's most complex environmental and social problems. Thank you so much for being here.
Thank you so much, Heather. And thanks, Christian. Drop the mic, man. All right. It's really an honor and pleasure to be here today. Again, I'm Miwa, and I'm here talking as part of the Biocultural Connections about the future and history of local adaptation. We can go to the next slide. So this is a photo here. You can see of a lokoi'a, and I think it speaks a lot to some of the themes that Christian was talking about. Really grateful to him for providing so much context. This is in Heia. Fish ponds are themselves, they are a form of traditional aquaculture and really products of adaptive decision-making. I think some of the earliest fish ponds in Hawaii have been dated back to the 1400s. And, you know, we're looking at about some estimates between 400 and 600 pounds of protein per acre annually being produced by fish ponds. So some estimates would say pre-contact, pre-Western contact, up to 2 million pounds per year, down to in the 1970s, we were looking at around 20,000 pounds per year. And so between the 1970s and now, really looking at a resurgence of interest and practice coming out of the Hawaiian Renaissance, a desire to reclaim biocultural connection with these places and to see them become productive. And that in itself is like a really important adaptation, and now facing the challenges of climate. So one on top of a host of so-called wicked problems. So next slide. I'm here actually today presenting on behalf of a group of folks. This is the Hui Malamalokui, one of the adaptations, I think, of recent generations who are seeking to affirm and reclaim ponds is the hui, to reclaim our relationships with each other and all of the knowledge and the good stuff, the technology that has to bring forward. So this map really shows, it might actually even be missing a few, but the ponds that are represented in this Hui Malamalokui, they've been meeting regularly since the early 2000s. And both Keawanui and Uncle Walter Riddy, as well as the gang at Paipai o Heia, are really founders of this hui, which is now facilitated by our organization, Kua'aina Ulu Awamo. And we had the privilege through this project of partnering with UHC Grant, as well as PI-CASC, to do the first comprehensive research needs assessment for climate adaptation for Lokoi'a, which is pretty exciting. So next slide. I won't read through all of these, but these are the project objectives, which is really what this looked like was getting folks together and capturing actually even conversations that they had had from previous years, some document review, and then doing really intentional qualitative thematic analysis of what we were hearing from this larger community of folks who surround our local, including the Kia'i, the folks who steward those ponds, who are out there every day, our research community, folks in government. Yeah. Okay, so go to the next slide. You can kind of see what this process looked like. So most of the focus conversations happened in 2019, but again, really, these conversations went back to kind of formal facilitation of the Hui, which started in 2014, and then even previous to that, really the seeds of those conversations going back into the 1970s, 80s, 90s, and 2000s. But this is what it looked like. Going on to the next slide. Let's see. So this is the model that arose from this project. Really, we call like six groupings or themes. I'm going to move from the bottom to the top. So we have Loina Velo, which is really about the foundational chants and stories, the canon of Hawaiian epistemologies that really underpin the practice of fish ponds and mokui'a, and that is continuing to evolve, right? We continue to add to that canon today. Ho'alaho is the physical manifestation of the pond, the physical restoration of the pond walls, the functioning of the ecosystem. Out to, you see i'a, those are our living fish, limu, microorganisms that really make the pond live, and which we seek to make space for and bring life to. And then, I'm not sure if you can tell, but this ring around where it says education, these are people. So this is really the community of folks that encircle our ponds. And then where it says Hui sharing, you can see that connection between two different groups that are stewarding ponds. So these connection between different ponds and the people who care for them. And then the He Hui Ho'okahi, which really has to do with the how we come together to push for systemic change. The ecosystem of our society, whether it's governance policies, global food policy, natural resources, laws governing natural resources, how we fund education, all of those things that allow our ponds to thrive. Next slide. So yeah, just to share some reflections. This was really a multi-year process of relationship building and knowledge sharing across the Hui Malamonokui'a, across this network of folks who care for fish ponds. And that we were applying a framework developed by the Kia'i themselves in assessing and analyzing needs. This is really a holistic and bottom-up approach, what we like to call radical listening, to what people need and what they're seeing, and also what the place needs and what the place is seeing. And that thriving through climate change really will require this holistic approach to adaptation that includes all aspects of community. I really loved watching Christian's presentation and thinking about what does it mean to, engage in a decolonized research needs assessment. It's pretty cool. So, really, if you go to the next slide, thanks really goes to, I want to say that I'm really here on behalf of Brenda Ascension, who provided leadership from KUA to this project. She had a baby a few weeks ago, so I'm here in her stead. Also, Katie Hinston, Darcy Yogi, Sharon, Rosie. Yeah, there's so many people actually, I think even on this webinar that really deserve so much gratitude for bringing this project to life. So yeah, I'll close with that.
Great, thank you so much, Miwa. Yeah, we were at PI-CASC pretty excited about this project, and that is a wonderful group of collaborators that you just mentioned. So I know that project is wrapping up, and we're excited to see what happens from here, especially with the report that you expect to put out regarding the needs assessment work. So we actually do not have any questions, but I think there was a comment in the Q&A if you wanted to check that out. And for time's sake, then we're just going to keep on moving. So thank you for that great presentation. Okay, next up we have Dr. Dean Gesch. Dean is a research physical scientist with USGS conducting topographic science research at the Earth Resources Observation and Science Center, or AROS, in South Dakota. He's the principal investigator leading Coastal Changes and Impacts focus area in the Integrated Science and Applications branch, with research topics including sea level rise vulnerability assessments, topographic change analysis and monitoring, hurricane storm surge mapping, elevation data accuracy assessment, and topographic data development and application. It's been a pleasure working with him, so take it away.
Okay, thank you, Heather, for that introduction. And thank you to the program organizers for the invitation to speak. I'm honored to be here today speaking on this topic. So we're going to look at a couple examples of coastal mapping, geospatial data, and the importance of that for studying sea level rise and coastal resilience, that general topic, the impacts of increasing water levels along the coast. So next slide, please. So this is just a headline from almost exactly 1 year ago, and it's really an example of the impacts, the severity of the impacts of coastal inundation in the Pacific Islands, in this case, RMI, or the Marshall Islands. And this audience probably doesn't need too many examples like this, but I just thought it was quite timely. This is an event-based inundation that can take different forms. We can talk about chronic conditions with sea level rise, or event-based inundations like this, high wave events. So just an example of the severity of those kind of things that impact populated places in the Pacific Islands. Next slide, please. So exposure and risk and vulnerability studies, all those sort of topics in island settings, it's an active science and research topic. So just some examples here on this slide. So the study in the upper left that was reported on in that article, that just came out a few weeks ago. Very interesting study, very striking, the results that are found there. You can see as the headline puts it. The upper right is an example of some extreme adaptation measures that are under study and consideration for the Marshall Islands. So when we talk about these exposure and vulnerability studies, there's many different types and levels of models that range in complexity that are applied to assess exposure and vulnerability. So they can take a lot of different forms. On the lower right there, there's not complete agreement in the coastal science community about the atoll and island futures, as seen there, a couple examples, but it is a big issue, and there's a lot of good work going on. Next slide, please. So in coastal settings, again, especially low relief settings, this might go without saying, but elevation is really the primary variable that determines inundation exposure. So regardless of the specific nature or type of the inundation exposure assessment that's being done, the level of complexity it can range from very simple to very complex physical process based. There's really one a important basic requirement, and that's that high accuracy geospatial data, specifically elevation data, are a critical requirement, and we'll have some examples of that in just a minute. Another thing to consider is that there have been assessments that have been done, regional assessments and even global assessments of islands, but they lack the really spatially explicit detail that's needed to inform local adaptation planning. And a lot of that is due just to the coarse nature of the topographic or elevation information that was used. So remote sensing derived elevation models, what we call DEMs, they can facilitate a much better work, or a much more accurate work for these assessments, because they result in high resolution and high accuracy. And then also how the data are used, specifically a rigorous accounting, a consideration of the data uncertainty, and how that factors in. In the Pacific, this was mentioned yesterday, but I'll reiterate. So for sea level rise assessments or coastal flooding assessments in the Pacific in particular, an important factor to keep in mind is that the IPCC projections for sea level rise in the Central Pacific are that it will experience greater sea level rise or greater water level increase than the global average. So that just adds to the severity of the problem. Next slide, please. So a case study or an example of a baseline inundation exposure assessment, in this case was for Maigret Atoll in the Marshall Islands. And this is where it takes advantage of high quality, and by that I mean high resolution, high spatial resolution, and high accuracy or high vertical accuracy, very, very detailed elevation information. So in this case, a 1 meter spatial resolution elevation data were produced from an extensive field campaign that took place over Maigret Atoll. And this took advantage of what we call UAS, unmanned aerial systems, or what are commonly known as drones, like Dr. Perroy was talking about earlier. So there was an extensive drone survey done, and then simultaneous ground control or GPS survey that was done. So the end product that you see kind of in the main image there on the lower right is an integrated, seamless 1 meter, what we call topobathymetric digital elevation model, or TBDEM. So bathymetry, that's really the submerged topography or the water depth. So that's derived from different sources, including hydrographic surveys, nautical charts, satellite imagery. On the lower left there is an example of where we use Landsat data and worldview imagery to derive some nearshore bathymetry. So that was merged with the elevation data that was produced or derived from the drone survey of the land areas, and that makes this integrated seamless model. The DEM itself over the land is what I would say LiDAR quality. So in terms of vertical accuracy, it really falls into the LiDAR class. I can give a number. If you're familiar with DEMs, it might be meaningful if not, but it's on the order of about 20 centimeters vertically. That's a significant advance over previously available data, just a huge advance. So, and then on the bottom there, many people have mentioned that partnerships are key, and that was certainly the case with this effort. Many, many partners and many, many participants. I couldn't even begin to list them, but you'll see the logos there of all the different groups that were involved with this. Next slide, please. So some of the results of the work, Maigret Atoll inundation exposure assessment, kind of 4 areas that are zoomed in on detail. On the lower left, you can see some inset boxes, kind of small, but this high accuracy data and the modeling, it really accounts for the data uncertainty, and that adds the ability to express results with specific confidence levels and probabilities. So that's another good advance. So for instance, we can use the IPCC terminology, like in the upper left, likely is the term that's associated with a 68% chance of inundation at a specific water level increase, and that's shown in that area. Both what's called marine inundation, or what comes from the from the ocean or the lagoon, and then also the low-lying areas that fall under a threshold that aren't connected. We also looked at where that inundation comes from, whether it's from the ocean side or the lagoon side. So this modeling approach allows us to do that. And the upper right is just another example of event-based inundation. This is a high wave event, and it works the same way. They both take advantage of the high accuracy data and the modeling approach. So these results are being incorporated into the Pacific Islands Regional Climate Assessment Report that's being prepared for the Marshall Islands. Next slide, please. So our work in RMI continues on the upper left with 4 additional atoll and island locations as shown there. The emphasis on the continuing effort here is really on building capacity, local capacity or technology transfer to the local stakeholders to be able to carry out these kind of mapping and assessment activities. In this case, it's a local NGO, the Marshall Islands Conservation Society, so a very important stakeholder and partner there. And then in the lower right, another example in a different location. This is an example of adding critical built structures that can affect flood propagation, coastal inundation. In this case, they were measured with very high accuracy terrestrial LiDAR, so that's brought in with the data that's collected from the aerial sources. A question before about drone-based LiDAR that was used in this case. So both imagery and drone-based elevation data, and then merged with the terrestrial LiDAR data. So the focus here is the impact of projected sea level rise and wave events on important cultural resources in a National Park Service unit on the Big Island of Hawaii. Next slide, please. So last one here, just listed what I would consider the key points and takeaways here. Really, the high resolution, high accuracy elevation models are really critical for spatially detailed coastal hazard exposure assessments, especially in low relief islands like the atoll example of Madro Atoll. So there's many widely available and widely used global elevation models. They're just not good enough. They're for this application. They're very successful in other applications, but they're just not good enough for spatially explicit assessments and really shouldn't be used as such. So as I showed here, drone or UAS elevation mapping is really was effective approach for these locations where standard, manned airborne methods are challenging logistically. We would love to have kind of standard airborne LiDAR collections done for many of these locations, but it's very expensive and logistically difficult to get those assets out into some of these more remote locations. So UAS is a good one. And also the capability for local stakeholders to be able to operate that. And as I mentioned before, UAS LiDAR is really the next step. So both topographic and bathymetric LiDAR can be flown on a drone. So that's really an emerging technology and shows great promise for this detailed high quality mapping that's needed. So no matter what the complexity of the modeling approach is, from a simple bathtub or to a full physical process numerical model approach, the quality of this input elevation data is critical, and then how that uncertainty is handled and incorporated into the modeling, that's really a must. So this confidence and probability is not just for estimates of the area, but then also an inventory of any features and resources that are connected or that fall within those areas. And these inundation assessments, coastal flooding assessments are a fundamental input for adaptation planning in these island settings. So I will end there.
Great. Thank you so much, Dean. I know that your work is really well received in that region, and we appreciate the partnerships you've developed. We only have time for one question to keep moving. Sorry for that. But there was a statement, then a question. I think the figure included a caption of how many individual photos went into the development of the DEM. Can you approximate the number of total ground targets that were used for the entire area included in the model?
Yes, if my memory serves me, yeah, there was on one of the slides that showed the number of high resolution, 5 centimeter resolution photos. For that area that was mapped, the southern portion of the atoll, it was on the order of about 100 ground targets. We learned a lot. We learned a lot of lessons doing this. We would do things a little bit differently. It was successful, but we would do things a bit differently and actually probably add more targets to that. But it was on the order of a little over 100 ground targets to tie all that photography together to make the elevation model.
Great. Well, thank you so much. And sorry we need to keep moving on. Please do check the Q&A section.
Okay,
for all the attendees, we have a couple more speakers left, so stick with us. I know we're a little over time. We've got still, again, these 2 great speakers coming up. And next we have Maigret. She's a manager with the National Park Service. She's a supervisory archaeologist and integrated resource program manager at Pu'uhonua o Haunau National Historical Park in South Kona, Hawaii, one of 12 national park units in the National Park Service Pacific Island Network. She and other National Park Service managers are developing scenario planning tools to assist with transformative management of coastal landscapes that will be inundated in the coming decades. Her background is in geography, and she has worked in archaeology and cultural resources management in Hawaii since 1988. We're so glad to have you here with your perspective. So thank you for joining us.
Okay. Thank you so much. Aloha and good afternoon, everyone. And I appreciate that gracious introduction. I'm a manager at the Pu'uhonua o Haunau National Historical Park. And today I'm going to talk a little bit about our concerns about sea level rise and our scenario planning that's being assisted greatly through our relationship with PI-CASC researchers. We're really talking about how we're going to visualize the future of this highly significant cultural site in South Kona, Hawaii. So the primary interpreted area of the park, and really the pulsing center of the park, is right in front of you. It's this lovely lava flat, or papa, which is the Pu'uhonua itself, which is translated means a place of refuge, renewal, balance. And the mission statement there on the right acknowledges the park's commitment to its meaning and expression and experience in contemporary Hawaii, as well as our commitment to telling the story of the past here. Inland of the Pu'uhonua is a place known as the Royal Grounds, or Kauwalu Malie, which is where the Ali'i Nui conducted the business and the rituals of their day. Very critical site here also is the Hale Okeawe, which is the heiau, or the halepoki, the mortuary place, the keeper of the revered bones of the highest ali'i, and it sanctified the Pu'uhonua. This is a sacred place for Native Hawaiians today, and it's our intention to be the caretakers and to protect that aspect of it as well. Next slide, please. So, you know, as part of our duties, we have some work to do to get ready for what's coming. And the first thing is that we really need to assess the sensitivity of the cultural and biocultural resources of the park first. And this includes things like all the dry set stone masonry, the anchiline pools, the historically significant coconut groves, and also the subsurface archaeological record that is very, very vulnerable and might be lost. But all of these things contain messages and information about the life patterns at Honanau, Keokea, and Ki'ilai, Ahupua'a, that make up the lands the park encompasses. We also need to get meaningful and visual information out to our community, both the broader community as well as Native Hawaiians with whom we consult on compliance matters and treatment of our most sensitive resources. We need to get information about what's coming about sea level rise inundations so we can have a full engagement, develop those research questions that the community prioritizes, and to attract that creativity and the insights and kind of the magic that happens when you get together with your community. And we also need to figure out what is the preservation of this place, which is our, it's our agency's duty to preserve and protect. What is that going to look like physically? How are we then, once we're engaged in that work, how are we going to transition to how we interpret this place, how we preserve its story, and how we relate these large scale landscape level changes with other similar changes that have happened in the Hawaiian archipelago. How are we going to tell that story? How are we going to relate it to stories that have been told in the past? Next slide, please. So, throughout our archives and throughout the administrative history of the park, we've got hundreds of pictures of cleaning up after the mess the ocean makes when the waves come in. Erosion has been happening here for a long time. It's not a new thing. It's our biggest threat right now. But after the Park Service came in and assumed the management responsibility in 1961, our superintendent, Russ Apple, took a great interest in things he was finding along the shoreline, which were the submerged cultural resources, the poho, the bait cups, the places where palu would be ground for fishing that were underwater. Not just at high tide, but some of them are underwater. And he got together with Gordon MacDonald and they published their 1966 paper on the rise of sea level in contemporary times at Honaunau, which they attributed to isostatic subsidence, the weight of the volcano pressing down. And that was going to be our big issue, which they figured was going to be about a foot every century. So if you put that together with what we believe is coming in the early 2030s, we're very concerned about what's going to happen in our landscape. So next slide, please. So, high surf comes in and batters the park. We get routinely every year our seawalls, which were built in the late 1920s when the county of Hawaii had the management jurisdiction over this place. They break, the waves come in, they expose the coconut tree roots there, they pull the cultural deposits out of the sand, artifacts, charcoal, that archaeological record getting taken out to sea. We've also had our share of battering by tsunami, and not just the one in 2011, but in 1909, when John Stokes from the Bishop Museum was at Honaunau, collecting stories and mapping sites and doing his archaeology work. He was told that the old heiau, which is in the Pu'uhonua, which was really unrecognizable at that time, had been destroyed by a tsunami in the time of Naihe, which can be taken to mean sometime during Kamehameha's time, but other people interpret that as a tsunami from the 1868 earthquake. So every year we clean this up, and it really depends on the swell direction has a big difference. If it's just a north swell, we're not too worried. If it's a straight west swell, we are battening down everything and very, very worried and up in the dark the next day to get out there and assess damage, because that's when we really get hit. So the variability in swell direction is a big part of trying to predict what's going to happen at the park. Next slide, please. All right, so what have we learned from extreme events? So what you're seeing here is the aftermath of the 2011 tsunami, when the tsunami waves surged into the royal grounds. That's the Great Wall in the background. It had a bathtub ring on it from the tsunami, in and out and in and out. And the park closed for a couple of weeks, and we mapped all the exposed cultural deposits. And the most important thing we mapped, though, was the inundation line. So we took that GPS out, and Adam Johnson, who was our manager at the time, got together with Sarah Dolan and Lisa Merrick, and they published a paper which became our de facto vulnerability assessment for archaeological sites in the park. Anything seaward of the tsunami inundation line became our most at-risk resources and helped us to move forward with this scenario planning process that the National Park Service climate adaptation strategy asks us to do. So we kind of took that as a proxy indicator, you know, bathtub ring as it was, but used that information to start figuring out what to do next. So we've got hundreds of archaeological sites, anchialine pools, historic coconut groves. All of these are going to be affected by this, you know, submergence, either constantly or periodically or more frequently. And when coconuts, for example, get submerged, they topple. So there's hundreds of them out there, but you know, you got to start understanding what's it going to look like out there if there's no coconuts left, that their feet are too wet. And we got an idea, a shock and a wake-up call about the scale of landscape level change that may be coming. So next slide, please. All right, so we have a pretty good idea of where the water is going to go, but what we're lacking are really effective visualization tools for scenario planning. And without those tools, it's difficult and a challenge to have some really creative thinking and scenario planning with our communities. So for example, Dean's presentation, one of the sites that they worked in was at the park last summer, he and Phil Thompson. And part of the reason why they came out and did the super high resolution mapping that they did was to try and get into more scenario specific swell direction, wet swell direction, scenario specific planning, and get into some of the micro topography effects that might make some places more vulnerable than others. We don't know how storm surge is going to behave either after the sand starts to leave. The geomorphology in the park is that we've got a perched sand deposit on top of pahoehoe lava. So as that sand progressively starts to go out to sea, there may be accelerations and threshold points that this new modeling can help us with. Or if the coconut trees start to topple over, they're holding the sand together right now, but when one goes, whoop, there's an acceleration. So what I really wanted to say here, though, is that this landscape level change is going to change the way, possibly change the way this concept of pu'uhonua is expressed to people who come to the park. There's really strong, meaningful, metaphorical relationships that are physically demonstrated through the upright coconut tree and the flat lava flat. These are all metaphors for ways of thinking about the interaction of natural forces in the park, and those may change. The power struggle or the equilibrium between the ocean and the land, that's changing too, but those are all stories. So there's a really, really rich metaphorical fabric going on in this changing landscape. So having the tools to visualize the change is going to get us to those really neat conversations that are part of adaptation. It's not all going to be grief and loss, but even grief and loss creates a story that can be about this place. Next slide, please. So we've got a few things going on at once. Dean referred to it, and I referenced the work from last summer to do the super high res generation of the DEMs from the airborne LiDAR work. Kurt Strolazzi has a more regional focus on assisting the national parks and getting visualization tools for inundation as well. And we have a related study. It's not a PI-CASC related thing maybe yet, but a NPS funded study on the geomorphology of the perched sand deposits with Chip Fletcher and Haunani Kane, which we hope can inform all of these efforts. And it's just been really, the last thing I want to say is that the PI-CASC science effort came to us with a beautiful knock on the door and has really opened up a lot of possibilities for us in the park that were not available for us without this partnership. It's really exciting, and these guys are coming over the wall with the science. They're not Jeff said to me, we're not just throwing it all over the wall at you, Marianne, we're gonna come with it. And that, to a manager, that is, it's music and it's joyous, and we're really happy about this relationship. Next slide. So nothing matters more than the relationship of people with the living pulse of the landscape at the Pu'uhonua now. That's what we're talking about here, and absolutely delighted to see what's going to happen with these studies that are in progress, and how this relationship can help us be better stewards of the land. So that's it.
Thank you, Marianne. I really like that last statement there too, that we can help you manage your resources. It is definitely great to have the perspective of the complexity of all the various things that you need to be managing in future climate scenarios. So we hadn't quite had that as well in this summit yet. So I appreciate it. Unfortunately, because of time, we probably need to ask you to go to the Q&A to see if there's any questions. Sorry about that, because I feel like we could talk forever about almost all the talks that we've had so far. So I appreciate you understanding that as we move to the final speaker. So thank you so much. That was great.
Thank you.
Our final speaker for this session, and we'll adjust our agenda after we hear from the next speaker, who is Yin-Phan Tsang. She is a trained hydrologist and modeler with a great interest in linking hydrology with ecosystems using multidisciplinary approaches. She investigates surface water processes and their implication in streams and their connected ecosystems. Thank you for being our final speaker in this session. Good to see you.
Hi, I'm Yin-Phan Tsang. I'm the barrier between you and the break. I'm the associate professor in the natural resource and environmental management in the University of Hawaii and Manoa. Heather was introducing, that I'm a hydrologist with a lot of research project and application that connects hydrology to stream ecology and conservation application. In the following, I would like to share with you and focus on the freshwater ecosystem as an example to explain the possible impact to our aquatic ecosystem on the climate change. Next, please. So some of you probably know that the freshwater ecosystem is unique in Hawaii and the US affiliated Pacific Islands. The native indigenous freshwater fishes, shrimps, and mollusks are the amphidromous or catadromous species. What that means is that they have this life cycle include the adult living in the stream, lay their eggs, larvae being flushed down the stream and out to the ocean, stay in the ocean for 3 to 6 months and come back to the estuarine as juvenile and migrate upstream and grow into adult and recolonize the stream. Next, please. On the other hand, we also know that species invasion is a serious problem in Hawaii and US APA. Hawaii is being called the extinction and species invasion capital of the world. Species invasion is not only threatened the terrestrial ecosystem, but also freshwater ecosystem. As other invasion, introduced species can alter community structure, ecosystem function, and native biodiversity. In the state of Hawaii, there have been more than 50 introduced species detected in the freshwater environment. And at least one introduced species found in all perennial streams. So species introduction to freshwater environment in Hawaii Island historically occur in 4 waves. Prior to 1900, a number of species were introduced by immigrant workers, primarily for food sources. And between 1900 and 1945, introduction largely occurred for mosquito control and recreational purpose. So from 1946 to 1961, various species were introduced for control the aquatic plant and for aquaculture as a bait fish or for recreational purpose. From 1962 on, the introduction primarily occurred for amateur home aquarium owners. They releasing their pet fish or pet aquarium species into streams. and other freshwater environment. Next, please. So as many previous talks have pointed out, that prolonged drought is threatening our ecosystem. And in a recent study that we investigated the long-term unregulated stream gauges across Hawaii, and on a lower left shows that they are recent 30 years stream flow trends. Both base flow and runoff have declined from 2 to 29%, and 57% of the base flow and 22% of the runoff show significant downward trend decreasing. So in addition, between 1967 to 2016, we found increasing intermittent stream flow occurring at 3 out of 23 streams that we study in Hawaii. In the middle figure, I am showing the Kaluanui stream on Oahu in the blue circle, which has the diverse native aquatic species, our stream species there. And also I'm showing the Awakahi stream on Big Island in the red circle, which has 0 native species. We investigated and illustrated on the right bottom figure, and we found that the Kaluanui stream, even though they show intermittency, which but it's no more than 25 days that show us the dashed blue line there, while Awakahi stream in the recent 2014 drought had a 60 days of no flow, which never happened in the last 50 years. So again, the prolonged drought is likely impact our freshwater ecosystem. Next, please. And another observation, we found that flooding timing is shifting. We know our native migratory species use a flood, or we call freshet, as the signal to beginning their migration. So basically they smell the fresh water flush down and use it to direct their direction to going upstream. So on the bottom left figure, showing the trends of the annual peak flow trend from 1970 to 2005. What we observed is that the amount of the peak flow decreased on many parts of the Hawaiian Islands, and with some exception on the northern of Kauai, and some part of Oahu, and some part of Maui. And most interestingly, we found that the timing of the peak flow is changing. The right figure shows that the timing of annual peak flow in black lines and highlight with red circle with the timing of the flood. We found the timing of peak flow is shifting earlier to the earlier of the winter. And when we're using the circular analysis, which show at the middle of the figure, the timing of the peak flow shifting from the late January in 1970s, as the red arrow pointing there, to the late December in 2005, which is the purple arrow there. So both the amount and the timing of the peak flow is changing, which might also give different signal to our migratory species. Next slide, please. So to summarize, I present the 2 significant results showing the changing of our streams and their impact to our freshwater ecosystem. So to protect our native species, we better maintain the connection and the natural patterns of the stream flow. The natural flow will keep the river mouths open and will provide a gateway for our native species to complete their life cycle. And the increased intensity and possible of the flood and likely flush all stream species out, including both native and the introduced species. But we suspect that the native migratory species will be able to come back and recolonize our streams. Yet the possible consequence of the changing flood timing need further study. So these native species like us, like living on the island, depending on the stream, like connecting the Mauka, the mountain, and to the Makai, the ocean, that define the Hawaiian ecosystem. So I always try to advocate this concept that stream is the interlinkage across our terrestrial, stream, estuarine, and even marine ecosystem. So by better taking care of our streams, we are better connecting and conserving our environment. One example that I'm currently helping the Department of Forest Services in Hawaii to monitoring the stream flow and sediment transport, to understanding how their forest protection and watershed restoration effort at Malkasai, and see if there's better or no acid sediment that being transported downstream to endanger our nearshore coastal ecosystems, such as coral reef. Next slide, please. So for the future climate adaptation, my group is conducting the hydrological simulation to assess the climate change impact on Hawaii stream, and of course their aquatic species. It's an effort that is supported by National Climate Adaptation Science Center. We are also making effort to connecting with estuarine and coastal researchers to make the connectivity from terrestrial freshwater and all the way to marine ecosystem. One of the goals is to identify the priority conservation area. Also, with collaboration with Hawaii Cooperative Fishery Research Unit, we are about to embark an experimental effort to set up a swim tunnel to examine the fish swimming ability to withhold extreme events. So stay tuned, please. Next slide. Thank you. That will be all my presentation, and I'm happy to answer any question here, Q&A, or in the breakout room. I will be there.
Thank you so much. That was really great to hear. I know you've been really involved with some of the CASC work, and it was good to see the slides. I would just like to direct everybody to maybe save their questions or discussion for the breakout sessions. I'm sorry, Yin-Phan, but just because to try and keep everybody on top, we might keep moving through. So again, her contact information will be made available, and you can also still pose questions in the Q&A, and we'll ask her to look at that. Now, we did get a comment of nice job. So we really appreciate that. I'm gonna hand things over now from this session to Brad Romine, who will be talking next about our breakout groups. Thanks so much for listening to our presentations.